All right, guys, how you doing? Hope everybody had a great day, weekend, all that good stuff. This should be a really short video for the most part because we've already done this. We did this in section 1.1 when we were talking about transformations of functions. Today we're going to talk specifically about quadratic transformations. This chapter is chapter 2, and chapter 2 is all about quadratics. All right. Remember, we talked about, before I go on to that, I sent you all an email. Many of you are not doing the worksheets. Starting today, it's going to kill you if you don't do the worksheets. All right? Fair warning, July 1st is the next drop date. If you're not doing these worksheets, you're going to be dropped on July 1st. So not a negative thing, just a real thing, just to let you know. I don't want anybody to get dropped or be unsuccessful, so you got to be sure to do the worksheets. All right, remember, this was our vertex form, and that was true for any function. We did it for linear functions. We did it for absolute value functions. A, remember, changes the width. H is the x value of the vertex, and k is the y value. So my vertex is at h, comma, k. The opposite of whatever's inside there. Remember our... Alright, that's a Freudian slip. Remember our parent graph. That looks weird. F of x is equal to x squared is our parent graph. These numbers up here are going to change where that vertex goes. And the points that we plot for that parent graph is 0, 0, 1, 1, 2, 4, 3, 9, as you all should remember. All right. So now then, I'm going to give you a couple of examples at most, I think. Because again, we have already done this garbage. I'm not going to graph the parent function because you know what that is. 0, 0, 1, 1, 2, 4. When you do these, if you choose to graph the parent function, that's fine. You don't have to graph it, but if you want to, that is absolutely fine. Let me move this over a little bit. And let's graph, I don't know, let's do a g of x. G of x is equal to x minus 5. Let's just do it like that for right now. We should remember that inside the parentheses, whenever there's a number inside with the x, since x goes horizontally, that's what that guy's going to do. It's going to move it left or right, opposite the sign. So this means that this guy, instead of starting at 0, 0, and you know what, I'm going to change that just because I don't have room over here in my graph, so I'm going to change this to, well, you know what, I'll just change it to x minus 2. Plus 2. G of x equals x plus 2. Alright, so since that's a positive 2, we're going to move to the right 1, 2. Since I do not have a k, I am not going to move up or down at all. I just move to the left 1, 2, and there's my vertex. Once I do my vertex, I've taken care of that 2, and I forgot, I'm sorry, this is squared because we're talking about quadratic. That should be squared. Alright, so now that I got rid of that 2, I have g of x equals x squared. So our points are just 0, 0, 1, 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then remember, this is going to be my axis of symmetry, the line that cuts right through the vertex. And then you have the sister points on the other side. And that is my function, g of x equals x plus 2 quantity squared. Easy enough. Now let's do h of x. Doesn't matter. These are just variables. They stand for y. We use h or g just to show it's a different function. H of x is, let's say it's x plus 3 minus 4. So my vertex here is going to be at the opposite of this, is going to be at a negative 3, and the same as that, negative 4. And you can do it the same way as what I just did. You can just plot the vertex, negative 3, negative 4, 1, 2, 3, 1, 2, 3, 4. That's not what I did just now, but just plotting that vertex. Now you can do it the way I said before, just to check. This says go to the left 3, that says get down 4. So I go to the left 1, 2, 3, I go down 1, 2, 3, 4, and there's my vertex. Alright, so it's either way. You can count it the way this is, or you can go ahead and plot the vertex and then move from there. Probably easier just to plot the vertex. Once you have that, we don't care about the 4 no more, because we've already used it, and we don't care about that 3 anymore. Do not cross these out on your paper, please. Remember, on your homework, you have to have graph paper. On Canvas, I gave you a link for that large graph paper if you need to use that. Alright, so once we have our vertex, we don't care about that anymore. All I have left, excuse me guys, you know we're doing quadratics, so don't forget to put that 2 there. You know it's there, even though I didn't write it, because the only way for a function to be a quadratic is it has to be squared. Alright, so now then, I just do my points. 0, 0, 1, 1, 2, 1, 2, 3, 4. There's my axis of symmetry. And then we go on the other side. Sister points the same distance away. And there is your parent graph. It looks identical to that, except my vertex has been moved off of the, whatchamacallit, origin. Alright? I think that's all I'm going to show you. That's all we need. I've shown you everything except for a, now let's do that one. Except for a stretch or a shrink. Remember, if A is greater than 0, that's going to be a stretch. That's going to make the graph skinnier. You go from here and it's going to make it skinnier. If A is less than 0, excuse me, that's right, 1. If A is greater than 1, less than 1, it's going to be a shrink. Okay, and that's going to make the parabola larger, because if you think about it, if you are having a parabola that looks like, get those pens out of the way, you have a parabola that looks like this, if it's a shrink, that means like something's being pushed down. It's shrinking. If it's shrinking and it's pushing down on that parabola, it's going to go like this, like a ball of clay. You got a ball of clay and you start to smash it down, it widens out. That's a shrink. Alright, so let's do g of x is equal to 2 times x plus 1 plus 2. I'll say minus 3. The only reason I'm changing that because I don't want this 2 to be confused with that 2. Alright, so now that we have that, we know that we are going to have my vertex is still going to be at the opposite of this guy, so it's a negative 1, and the same as that guy, negative 3. So once I have my vertex, I can go ahead and plot that guy, and that's going to be at, from my original 0, 0, I'm going to go to the left 1 and down 1, 2, 3. That's my new vertex. I don't care about him. I don't care about him. And golly, gee whiz, I keep forgetting my exponent. But you're not. That's squared. Now all I have is my parent graph, which is f of x is equal to x squared, but now I have that multiplier in front of it. So then we go, we go from 0, 0, then we go to 1, 1. But instead of 1, 1, we have to go up 2 because of that multiplier. When x is 1, y is 1, 2. When x is 2, y is usually 4. But now because of that multiplier, it becomes 2 times 4, which is 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There we go. My axis of symmetry is x equals a negative 1. My sister point is there, and my other one is there. 2 units away, 2 units away. There is my, whoops, oh, that was bad. There goes, whoop, that was even worse. There goes that guy. It doesn't want to go through the point. That's okay. You know what I'm talking about. And you'll notice this guy is skinnier than either one of those two because that 2 is greater than 1. It makes it skinnier. All right, do not forget everything you need for that homework. Zoom is from 9 to 10 this morning and every morning until Thursday. See me there if you need to. Goodbye.